Today we're still going to be thinking about tables, and you may be thinking, do these tables give us real life information? Kind of like, what's the point? Well, they do kind of tell a story, and we're going to look at today what story they tell and mathematically what's going on within that story. I know many of you told me that language arts was your favorite subject when I asked for favorite subjects earlier in the year. So for those of you that really like language arts, you can think about this more as a storytelling, and then we just note what's happening in the table. So if we look at our first table and think about it like a story, it says each hot dog costs $2. So if like X would represent the number of hot dogs, and then Y would represent how much money we are spending. So in this particular narrative or story, you could say, okay, for one hot dog, I'm going to obviously pay $2. Well, if I get two hot dogs, I have to pay $2 for the first one and $2 for the second one, which is going to end up costing me $4. And then if I get three hot dogs, I have to pay $2, $2, and $2, which means I end up paying $6. So this table is telling me how much money I'm going to pay in compared to how many hot dogs I get. So if we want to write, this is like our sentence or our story that each hot dog costs $2. Well, if we go back to yesterday when we were looking at we were solving for equations, and we had like y equals something. Well, in this particular problem, what would y equal? Well, we know that each hot dog cost $2. So if we go back, what happens to this x for this y to equal it? So I'm thinking if it's $2 times how many hot dogs you get, then we would have 2 times x. Because if we do 2 times 1, we get 2. 2 times 2 gives us 4. 2 times 3 gives us 6. And then if we keep filling this table out, 2 times 4 gives us 8. 2 times 5 gives us 10. And then 2 times 6 gives us 12. So we could continue this table forever if we wanted to, or if I just said, okay, I want to order for the whole 7th grade and I want 98 hot dogs. Well, you've written the formula or the equation, not the formula, the equation, and we know that we have to say 98 times 2. So if you want 98 hot dogs, then you can do 98 times 2. And that means that you're going to spend $196 for hot dogs. Okay? So if we look at the next, if you want to think of it like a story, it says each chair costs $15. So if each chair costs $15, we know that if we get one chair, that is $15. If we get two chairs, that's going to be 15 and 15, which gives us 30. And in this, if we get 3 chairs, we get 15, 15, and 15, which gives us 45. So if we go and try to write an equation like we were working with yesterday, y equals, what is it that we do to this x every time? Well, it says $15 each. So we would do 15 times x. So 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45. So then we're going to do 15 times 4, and 15 times 4 is 60. And then 15 times 5, 75, and then 15 times 6 is 90. So it tells us we can complete the table, or if I tell you that I want to order 36 chairs for my room, for my classroom. Then to figure out how much those chairs are, I've written the equation over here. So I would do 15 times 36. And now I know that I'm going to spend $540 on chairs if I need 36. I don't have to keep that table going all the way to 36 because I've written a rule for it. Okay, here's our story, and I've written a rule for that story. Okay, so we might get just a little bit harder. Okay, it says that Hoel spent $5 minutes. We'll take these out. Spent 5 minutes getting out his tools, and then it took him 2 minutes to cut the boards. So this one's a little bit different. We got 5 minutes. He got all of his tools set up, and he did that in 5 minutes, and then it took 2 minutes to cut each board. So if we think about what's happening with one board, well, he got 5 minutes to cut it out, to get his tools out, and then 2 minutes to cut it out. So he spent 7 minutes. Now, where it starts to get a little bit confusing is, okay, if I'm going to cut 2 boards, do I have to use 5 minutes and 5 minutes? And 2 and 2? Or it says that he spent 5 minutes getting his tools out. So he only has to do that one time. So what's happening here is really like 2 minutes to cut the boards, plus 2 minutes to cut the second board, plus the 5 minutes that it took him to get organized. So what's really going on here is it's going to take 9 minutes. Here we cut 3 boards, so we cut 2, 2, and 2 minutes, and then plus the 5 minutes that it took to get those tools out. So that's going to be 2, 4, 6 plus 5 is 11. So I want to see if I can write some kind of rule that's going to always work, so that if I wanted to cut 280 boards, I could figure out how to do that without having to take this table all the way to 280. So I've got my y equals, I'm trying to figure out what is happening. So to my x, every time I cut a board, it takes 2 minutes. So 2 times however many boards I've got, plus the other thing that's happening is we do that 5 minutes one time. So that's why we only have 5 up there one time, is because it only happens once. So now I could put, let's go back and check this. If I put this x is 1, so 2 times 1 gives me 2, plus that 5 gives me that 7. Okay, here if I try the 2 for my x, 2 times 2 is 4, plus that 5, it does go back and give me that 9. So 2 times 3 gives me the 6, plus the 5 gives me the 11. So that rule is going to work every time. So let's try 4 times 2. 4 times 2 is 8, plus 5 is going to give me 13. And then do 5 times 2, which is 10, plus 5 is 15. And then do the 6 times 2 is 12, plus 5 is 17. So if we write that rule, that would be quicker than coming down here and saying 2 plus 2 plus 2 plus 2 plus 2. So that's 1, 2, 3, 4, 5. I need one more 2, and then plus a 5. So if we can write a rule, we can get to the answer much faster. Okay? So then we got 2 more. It says Destiny paid a tow truck $10 to take her call, and then he charged $25 per hour. So this is the same concept, but we changed the way the table looks. So this $10 only takes place one time, and this takes place each hour. So however many hours we go, we've got to pay that $25. So for this one, we're going to pay $25 because we only are doing this for 1 hour. So we got to pay the 25 plus the 10 to take the call. So this is going to be 35. Now this one, we got 2 hours. So if we wanted to write there, here we could change this to hours, and this is talking about how much money we pay, the X and the Y. So for 2 hours, we got to pay $25 for the first hour, plus $25 for the second hour, plus that $10 one time. So that's going to be $50 plus 10 gives us 60. So if we're going to do 3 hours, we've got 25 plus 25 plus 25 plus 10. So 25, 25, and 25 is 75, and 10 makes 85. Well, the further we get, that's going to get to be more and more time consuming, so we're going to see if we can write an equation. So then y equals 25 times however many hours, so that's times whatever x is. So 25 times x, however many that may be, and then plus 10, because that 10 only happens one time. So if I tried this one, I would say 25 times 4, which gives me 100, and then plus 10 is 110. For this one, I've got 25 times 5, which is going to give me 125, and 125 plus 10 is 135. So if I had the big number, like if I said it took the tow truck 18 hours, then you could come in here and do 25 times 18, and then plus 10, and that would let you know what you would have to pay that tow truck driver for 18 hours. Okay, so let's do one more. Okay, David opened a video gaming store. He charges $3 to get in the store and then $10 per hour. So if you notice, again, this is the hours and this is the amount of money. Now, this does not always have to be 1, 2, 3, 4, 5, 6. It doesn't have to be, it should be consecutive. It doesn't have to be, but best practice is to be consecutive. But if you see here, I don't have it consecutive because I wanted to do it different just sometimes, because you may see it differently sometimes. So we get charged $3 just to walk in the door. It's kind of like going to the fair. You get charged just to walk into the fair. So David's going to charge you $3 just to come into his store, and then $10 for every hour. So for here, you're going to spend 3 hours. So that's going to be 10 plus 10 plus 10 plus the 3. So you're going to have to pay $30 for the hours plus the $3 to get in. So your total bill would be $33. Now this person stays 5 hours. So 10 plus 10 plus 10 plus 10 plus 10. So that's 1, 2, 3, 4, 5 hours plus the 3. So that's going to be 53 hours. So if we wanted to write an equation for that, we're going to say y equals how many hours we stay, 10 times that many hours. So let's go down. We can work it. We don't always have to go straight down. Let's say we went 10 times 8. 10 times 8 is... Okay, some announcements started and I paused it and tried to start back. So I think, I'm not sure that it's going to quite be streamlined. But anyway, what we were saying is if we say 8 times 10 is going to be 80, and then plus the 3. Plus this 3, which is the $3 to get in. Whether we go to the 6 or the 7, we're going to say 6 times 10, because it's going to be $10 per hour. So 6 times 10 is 60, plus 3 is 63. And then 10 times 7 for 7 hours, plus 3 is going to be 70, plus 3 is 73. So you've got a storyline, we're going to make an equation, and we're going to fill out some tables.